What if you could be the architect of life itself? I mean, not just editing the blueprints, but actually drawing them from scratch. Well, in this explainer, we're diving into a scientific revolution that's making that a reality by designing the architectural blueprints of the proteome.
Just imagine for a second, designing brand new medicines, crazy new materials, all of it not just in a lab, but from the atoms up, like an architect designing a skyscraper. For the longest time, this was pure science fiction, right? But as you're about to see, things have fundamentally changed.
Okay, but before we can get ahead of ourselves and start playing master architect, we really need to understand the original designs. So let's start with nature's own incredible tiny machines.
And those machines? They're called proteins. They are, without a doubt, the workhorses of every single living thing on this planet. Forget gears and pistons, these are the biological nanobots that do it all. They digest your food, they carry oxygen in your blood, they form the very structure of your muscles. They do literally everything.
Now this analogy here, this is at the absolute heart of everything we're talking about. Think about it like this. To build a skyscraper, you need a blueprint, an architectural drawing. In biology, that blueprint is our DNA. For the building, you need materials, bricks, steel, glass. For a protein, you need a set of 20 building blocks called amino acids. And in both cases, what do you get? A complex, functional structure that's built for a very specific job.
So that's how nature's been doing it for billions of years. It's a pretty good system. But here is where the story takes a radical, incredible turn. We are now moving from just reading the old blueprints to drawing our own. For the longest time, biology was kind of like archaeology. We could find these amazing protein structures out in nature, study them, and try our best to figure out how they worked. We were basically reverse engineering these incredible molecular machines that evolution had already built.
But all of that has changed. We are no longer limited to the library of life that evolution gave us. We can now literally sit down at a computer and design a protein that has never ever existed before in the natural world. This is such a monumental leap forward.
And this revolution, it has a name, and it's one you should definitely know. This comes from the work of pioneers like David Baker, whose lab has just been at the absolute forefront of this field. The breakthrough is called computational protein design. It's the ability to dream up a new biological machine and then actually go and build it.
So how does this actually work, right? I mean, how do you go from an idea on a computer screen to a real functioning molecule in the real world? Well, the process itself is just as revolutionary as the idea.
It's this fascinating blend of imagination and pure computation. So first, it starts with a clear goal. What problem do you want this new protein to solve? Maybe it's targeting a cancer cell, or maybe it's breaking down plastic. Next, incredibly powerful software acts as your architect, modeling the perfect 3D shape to do that job. Now here's the magic. The computer then works backward. It calculates the precise DNA sequence, that string of amino acids that will naturally fold itself into that exact shape, all based on the laws of physics. And finally, that digital blueprint gets sent to the lab, where scientists synthesize that code and bring the new protein to life for testing.
The key takeaway here is this. We're not just editing the book of life anymore. We are writing entirely new chapters filled with molecular machines that nature, in billions of years, never even dreamed of.
And that brings us to the final and, arguably the most exciting part of all this. What can we actually build with this new architectural power?
Why should you care about any of this? Because the ability to design proteins from the ground up, it's poised to change everything, from the medicines we take to the materials we use every single day.
I mean, the potential applications are just staggering. Think about it. Vaccines that are custom designed in advance to neutralize a brand new virus before it becomes a pandemic. Or drugs that are so precise they only attack cancer cells, leaving healthy cells totally alone, eliminating side effects. We're talking about custom-built enzymes that could literally digest our mountains of plastic pollution, or even proteins that self-assemble into tiny wires for new kinds of electronics. Any one of these would be a world changer.
So, this is where we're left. For the first time in human history, the blueprints of life are in our hands. We now have the tools to design and to build at the most fundamental molecular level. And that leaves us with maybe the biggest architectural question humanity has ever faced. What do we want to build?